In this video, we're going to look at using the binomial distribution in 3 different exam questions. So there's 3 different ways of doing these questions. I'll go through the easiest one, which I think is using the binomial PD and the binomial CD function on your calculator. I will also show the other ways you can do this question. I'm stuttering a little bit because I'm thinking of which way to go through first. But yeah, let's go through binomial PD. So we can use the binomial PD function whenever we want to find the probability of x equaling a variable. We can use the binomial CD function whenever you want to find the probability of x being less than or equal to a variable, or when you want to find the probability of x being greater than or equal to a variable. Also, when you want to find the probability of x being less than a variable or just greater than a variable. Let's talk about this a little bit further. Let's say you want to find the probability of x being less than or equal to 4. That includes 0, 1, 2, 3, and 4. However, if you want to find the probability of x being less than just 4, so not less than or equal to 4, that means you don't include 4 in your data. So you're only interested in 0, 1, 2, and 3. Just something to be careful of. The same works on the upper side of things. If you want to find the probability of x being, let's say, greater than 4, then that doesn't include 4. That includes only 5, 6, upwards, up to the limit, which is n, or 11 in this case. N is just the sample size. For the first part of the question, it says, given that p is equal to 3 over 4, find probability of x equaling 5. Like I mentioned, to find it equaling something, you can just use the PD function. There is also another equation that you can use for the binomial. I don't want to confuse you, but some students, they like to know like all the different ways, which is why I'm going through it. N just refers to the sample size, 11. C is just the choose button on your calculator. So for me, it's above the division button. I can see NCR. So if I click, let's say 11, the sample size, and then choose, and then R represents what you're trying to find it equal to. So in this case, 5. So in our calculator, we'd put in 11 choose 5, and then in the brackets, the probability of it happening, of x actually occurring, which is given as 3 over 4 in this question, all to the power of r, which is the x value that we're making it equal to, 5, multiplied by 1 minus p, which is 1 minus 3/4, so that's 1/4 to the power of n minus r, which is the sample size of 11 minus r, which is 5. 11 minus 5 is 6, and putting all of that into your calculator will get you the final answer. So in this case, I'm going to do 11, and then shift divide to get the choose function, 5 on my calculator, and then I have 3/4 all to the power of 5 multiplied by 1/4 all to the power of 6. Okay, so it actually gives a math error on my calculator. I wonder why that is. Okay, let's try using the CD function then. So depending on how you get to the PD function, sorry, not CD, PD function, for me, it comes up with 3 different variables, x, n, and p. X is what you're making it equal to, so that's in this case 5. N is the sample size, which is 11 for this question, and p is 0.75. When you put all of that into this function, so 5, 11, and 0.75, you'll get a value of 0.0267, or 0.0268, sorry, when you round up. And that's your answer to part I. So I'm just going to erase some of this. I just realized I inputted this incorrectly in the calculator, which is why. But yeah, I got that same value as well, 0.0268. Those are 2 different ways you can find the probability of x equaling a variable in the binomial distribution. Okay, let's now move on to part 2. It says, given that the probability of x equaling 0 is 0.05, find the value of p. Now this, you can do it through trial and error. You can keep, so on the binomial PD function, like I mentioned, there's 3 variables, x, n, and p. X is 0. We want to find the probability of p. We want to find the probability of p. And then n is the sample size, which is 11. However, if you keep inputting decimals for p, you can eventually get to a final answer of 0.05 when you press equal on the binomial PD function, but it's quite a tedious process. This is where using that formula can be quite useful. The probability of x equaling r is equal to n choose r multiplied by the probability of r multiplied by 1 minus the probability all to the power of n minus r. In this case, the probability of x equaling 0. So by the way, r would be equal to 0. P would be what we're trying to find. And this whole left-hand side, by the way, would be equal to 0.05 because that's the actual probability that comes out. So 0.05 in this case is equal to the sample size n, which is 11, choose of the value of r, which is 0. All of that multiplied by the probability, which we're trying to find, to the power of r, which, like I mentioned, is 0. All multiplied by 1 minus p, the probability of n minus r. Now, n is a sample size of 11. Take away 0 is 11. Now, anything to the power of 0 is just 1. 11 choose 0 is also 1. So we have 0.05 is equal to 1 minus p all to the power of 11. You then have to do the 11th root of both sides. So the 11th root of 0.05 would be equal to, well, doing the 11th root of this function here will just leave you with 1 minus p. You can then subtract 1 from both sides. So it'll be the 11th root of 0.05. Take away 1 is equal to minus p. You can then multiply both sides by minus 1. So you get plus 1 here and minus here. Now, putting all of that into your calculator will get you the probability that you're looking for this question. So I'm just going to very quickly do that. 1 minus the 11th root. So the 11th root of 0.05. And that gets me a value of 0.238. So basically what that means is when the probability is 0.238 and a sample size of 11, the probability of x equaling 0 is 0.05. Great, let's now move on to the last part of this question, part 3, where we have to deal with the variance. Now the variance is, by the way, just a quick recap, the mean of x in the binomial distribution is given by the sample size multiplied by the probability. The variance is given by sample size times probability, so the mean, but then you multiply onto that 1 minus p. In this case, the sample size of 11 multiplied by the probability that we're looking for, multiplied by 1 minus p, is all equal to 1.76. It helps here to expand out the brackets. So 11p times 1 is 11p, 11p times minus p is minus 11p squared, and all of that is equal to 1.76. Now, it probably, well, it is a quadratic, and you want to take all the terms to one side before you solve it. So I'd recommend taking everything to the right side, because I always like the number before the square term to be positive. And then we have minus 11p when you take that to the right side, plus 1.76 is all equal to 0. From here, I'd recommend using the quadratic formula, which I'm just going to very quickly do. I'll write it out here for you guys in case you want to use it. If you would like me to make a separate video, just quickly recapping how to go through the quadratic formula, just do let me know. But yeah, I'm just going to very quickly do on my calculator. Square root of b all squared minus 4 times a times c all over 2a. That will all equal 0.2, so that's one value. The 0.2 value I got when I used a minus. So let's now use a plus and see the other p value. When you do use a plus, you'll get a value of 4 over 5, or 0.8. And those are your two p values now for this case. So that's everything for this video. Hopefully it made sense, and yeah, hopefully you guys understood how binomial PD and binomial CD can be used. Actually no, I'll make a separate video about the binomial CD function because it's not really involved in this question. Thanks for watching your video. I hope it helped. If you have any tutoring inquiries for A-level further maths, be sure to hit my website up at www.excelineducation.co.uk.